Hello! Today, on this video, we'll be talking about direct variation. Direct variation is a way to create a mathematical model for a real-life system that allows you to say, given one variable, another variable changes according to some constant that's called a proportionality constant multiplied times that other variable. A very simple example is something that you'd be able to calculate in the grocery store. Let's say the variable A is for the amount of apples. Okay? And let's say the variable P is the price per apple. Okay? And let's say the variable T is equal to total price that you have to pay. We say that the variable T is directly proportional to the variable A. Meaning T is equal to some proportionality constant K times A. K is a proportionality constant. Okay? And in this case, our K is the same as P. So let's say I go to the store and each apple, the price per apple is $1, okay? And the amount of apples I buy, let's say I'm really hungry, I buy 20 apples, okay? What is the total price? Well, we all know this. It's 20 times $1, so $20, that's the total price. So what you're really doing is you're saying total price is equal to the proportionality constant here, in this case P, times the number of apples you bought. So the total amount of cost you must pay is the price per apple, $1, times 20 apples. So the total price you'll have to pay at checkout is $20, if we don't include tax. But such a simple idea can be applied to a myriad of more complicated ideas. Okay? So, for instance, one of the things that I like to talk about a lot is theoretical physics. And let's talk about an electron. Let's say E is the strength of the electric field. Of an electron. And let's say R is the distance away from a detection point. What if, at this point, now I'm going to say E is directly proportional to R. E is directly proportional, or varies directly. Another way to say it is E varies directly with R. This implies that E can be re-expressed as some proportionality constant K times R. Okay? So E is the electric field of an electron, K is some number, we don't know it yet, and R is the distance away from a detector. So we can draw it out. Here's my detector apparatus over here, and the distance away is right here is R, and here's the electron, and it emits an electric field, and the strength that the detector feels of the electric field is calculated by how far away it is, okay? Let's say, given the electric field is 100 when the electron is a distance r is equal to 10 away. I won't put units because that'll make it very complicated. It could be 10 femtometers, it could be 10 picometers. We won't talk about that. We're just going to do the math just to understand this concept here. We won't make it complicated with real physical distance units. Okay? So let's say the distance is r, the electric field is 100. What is, so this is the question, what is the electric, what is E whenever the distance r is equal to 1? So when it's much closer to the detector, how strong did the electric field get? Okay? So the way we solve this problem here is first we must solve for K. Okay? The way we do that is we have three variables in this equation. E is equal to K times R. We were given information about E, and we were given information about R in this first statement right here. We'll use that to solve for K to answer the second statement. Okay? The first statement, E is equal to R times K. They tell us E is 100. We don't know what K is, but we know what R is. It's 10. Okay? We can algebraically solve for K. So K is 100 divided by 10, which is 10. So I know now that K is equivalent to 10. Here, now I want to know what is E when R is equal to 10. Well, again, E is equal to R times K, and I know K now, and I know R, and I hope to find E. I know R is 1 now, and I've algebraically solved for K, which is 10. I can find E. So E would be equal to R, which is 1, times K, which is 10. So E will equal 10. And that is one example of how to solve direct variation problems. You'll be given some information at first. You'll utilize that to solve for K. Whenever you solve for K, you'll use that information to solve for another variable in the problem.